Okay, what I'm going to try to explain to you in this video is basic distribution of multiplication over addition and subtraction, okay? It is a skill that you have to have in order to have any kind of understanding of college algebra and any higher level of math. Distribution is a very, very foundational and pretty important concept within mathematics. Okay, so we know what a term is. Let's say that we had the term 3x. And let's say that we wanted to multiply this term 3x times a larger expression. So this is a single term expression, 3x. Let's say we wanted to multiply it by the expression 5x squared minus 9x plus 2, okay? And the reason that I put this three-term expression in parentheses is because it's going to be multiplied by this single term, and the way that we accomplish distribution is we have to multiply this term one at a time and separately by each one of these terms, okay? We can't just multiply the 3x times the 5x squared. That's not good enough. We can't multiply the 3x just by the negative 9x and not just by the 2. This 3x, this term, when you multiply an expression times another expression, you have to multiply every term in the first expression times every term in the other expression. So, since we are multiplying one term times an expression of 3 terms, we are going to have 1 times 3 multiplication products, okay? And 1 times 3 is 3. Therefore, when we do this distribution problem, we should wind up with 3 terms, 3 different products that will then be adding and subtracting with one another, okay? So let's see what that looks like. We're going to do 3x times 5x squared. So we learned how to multiply terms that have exponents. So 3 times 5 is 15. And then x times x squared is x to the first power times x to the second power. So that'll be x to the 1 plus 2 power. So that's x to the third power, okay? Another way to understand that is here's 1x, here's 2x's. We're multiplying 1x times 2x's, and so we wind up multiplying 3x's, okay? So we have 15x to the third power. Now our second product is going to be 3x times negative 9x. 3 times negative 9, that's negative 27. X times x, that's x squared. And then we have 3x times positive 2. So 3x times positive 2. 3 times 2 is 6, so that's plus 6. There's an x here. There aren't any x's here, so that gives us just one x. And as you can see, we wound up with 1, 2, 3 products. And so we have 1, 2, 3 terms. The next thing we would do is we would look to see if any of these terms are like terms that can be combined. As you can see, they are not. This term has x, but to the third power. This one has x to the second power, and this one has x to the first power. Therefore, no like terms. Therefore, we cannot combine any of these, which means that this is our final answer to this distribution problem, okay? Let's try another example. All right, so we have this one here. What I recommend you do is why don't you go ahead and pause the video, and why don't you try this on your own, and then you can unpause the video, I'll do it, and see if you got the right answer. Okay, so what we see here is we have a single term expression being multiplied by a 2-term expression. We often refer to a 2-term expression as a binomial, bi meaning 2, okay? Nomial meaning polynomial, but we'll get to that later, okay? All right, so since we have a 1-term times a 2-term, we should just wind up with 2 products, okay? So we're going to do x to the third times 2x to the fifth. Well, there's a 1 in front of this x to the third, so 1 times 2 is 2. X to the third times x to the fifth, we add the 5 and the 3, we get an 8. and so this is 2x to the 8th power. Then we're going to multiply the x to the third times this other term, negative 7x squared, and 1 times negative 7, that's negative 7, and then x to the third times x squared. Well, we're going to add the 3 and the 2. That's going to give us x to the 5th power, x to the 5th. Here's our two products. As you can see, they are not like terms, therefore we cannot combine them, and therefore this is the answer to this distribution problem. Okay. Now what we're going to do is we're going to do a two-term expression times a two-term expression. All right, so what we have here is we have two binomials. Note that we are separating them out by parentheses. That is necessary. If these parentheses were not here, okay, if what we had was x plus 5 times this binomial x minus 3, we would only distribute the 5 to the x and the negative 3. This x would not be distributed because this x is not included in the multiplication unless we had another x minus 3 sitting right in here, okay? So in order to communicate that we want to multiply the whole binomial x plus 5, it has to be inside of parentheses. And so we've got this x plus 5 inside of parentheses being multiplied by this x minus 3 inside of parentheses. And so what we have going on here is we have a two-term expression being multiplied by another two-term expression. And what that means is that we're going to wind up with 4 products. 2 times 2 is 4. We're actually going to have 4 products of two terms. And so in the end, in this particular case, we're going to have to combine like terms. But that won't always happen, okay? All right, so let's see what we're going to do here. This x has to be multiplied by this x, but this x also has to be multiplied by this negative 3, okay? Every term over here has to be multiplied by every term over here. So the x will have to be multiplied by the x and the negative 3, and then the 5 will have to be multiplied by the x and the negative 3. Now, one way to represent this mathematically, and this is a great way to understand, is to start with the x and write it out as being multiplied by the x minus 3. Then put your plus 5 and show your 5 being multiplied by your x minus 3. And so if we were to do it like this, it would turn out the same way as if we just went from here to here and here, and then from here to here and here. So these are a couple ways of showing how you're going to do this distribution, okay? So let's leave this one alone just for a minute and come over here. Let's pretend that that's not there. Let me show you how a lot of people wind up doing this distribution of two terms times two terms. What they'll do is they'll multiply the x times the other x, and they'll get an x squared. Then they will multiply the x times the negative 3, and that'll give them negative 3x. Now that they have multiplied the x times both the x and the negative 3, they can now multiply the 5 times the x, and that'll give them plus 5x. Then they can multiply the 5 times the negative 3, and that's negative 15. And so these lines, these curved lines, show you the 4 products of the two terms times the two terms. There's one product, there's another product, there's a third product, and there's a fourth product, okay? Now, if we look at this, distribution here, this expression, you can see that negative 3x and plus 5x, those are like terms. Therefore, they can be combined. And so, there is no other x squared, so we're just going to bring that down. Negative 3 plus 5 is 2. So we're going to make that plus 2, and we're going to put the x on it, because each one of these has an x to the first power. There is no other constant term except this minus 15, so we're just going to write minus 15, and that is our final answer for this distribution, okay? Now you may say, well then what about this thing over here? I see how you wrote that out. You did the x times the x minus 3, then you added on the 5 times the x minus 3. Well, if we were to do these two separately, watch what we would get. X times x is x squared. x times negative 3 is negative 3x. Okay, we're done there. 5 times x is plus 5x. 5 times negative 3 is negative 15. And look, it winds up being the exact same thing that we had before, and it gives us the same answer. And what I'm trying to do here is I'm trying to show you at least a couple different ways of doing the same problem, because one of these may be preferred for you, or maybe the other one is preferred for you. But either way, they both work, okay? Let's try another example. Okay, so here's another two-part expression being multiplied by another binomial two-part expression. Why don't you go ahead and pause the video and try this one on your own? All right, so what I'm going to do is I'm going to do this both ways, just like we did before. One way we could do this is we could multiply the x times the x minus 9. So that's x times x minus 9. Then we have negative 7 or minus 7. So over here I can write minus 7 times the x minus 9. X minus 9. I'll go ahead and do this one first, and then we'll do it the other way. Okay? So over here I would have to do the x times the x, which is x squared. Then the x times the negative 9, that's negative 9x. Now here, be very careful. We're not just going to do 7 times x. We're going to use the whole negative 7. Negative 7 times x is negative 7x. And then negative 7 times negative 9, that's plus 63. And then as you can see, we have two like terms right there in the middle. We have negative 9x minus 7x. So we'll bring down the x squared. Negative 9 minus 7, that's negative 16. So minus 16, and we'll put an x on there because each one of them has an x. And then we'll bring down our plus 63, and this is our answer, x squared minus 16x plus 63. Now, we could do it the other way where we don't rewrite it, where all we do is we do the x times both of these, then the negative 7 times both of these. X times x, that's x squared. X times negative 9, that's minus 9x. Negative 7 times x, that's minus 7x. Negative 7 times negative 9, that's plus 63. And again, we have our like terms in the middle. So we'll bring down our x squared. Negative 9x minus 7x, that's minus 16x. And then plus 63. And as you can see, we have the exact same answer that we had in the other method that we used. Okay? I think we should do one more example so that you can feel pretty confident about distribution. All right, this one is just a little more difficult, but I think that you can handle it. What we have here is we have a two-term expression being multiplied by a three-term expression. And so since each one of these two terms has to be multiplied by each one of these three terms, here's what we're going to wind up with. 2 terms times 3 terms, which means that we're ultimately going to have 6 products, 6 terms. Now, it's possible that some of those may be able to be combined because they might be like terms, but it's also possible that none of them can be combined. Let's try this out. Can we do both of the two different techniques on this? We sure can. Look at this. We can say, well, we know we have to multiply the 3x by the entire expression. So over here we can put 3x times x squared plus 2x plus 6. Then we have to multiply the negative 7 times this entire expression, which would be minus 7 times x squared plus 2x plus 6. And so you can see we're going to wind up with 1, 2, 3, 4, 5, 6 products. 6 terms that are products of 2 terms, okay? Let's do that one second. Let's go ahead and do it the way where we draw the curved lines, okay? So what we'll do is we got to multiply the 3x times each one of these 3 things. So we're going to do 3x times x squared. Well, that's 3 times 1, so that's 3, and then we have 1x here and 2 more x's here, so that's x to the 3rd power. Then we're going to do 3x times 2x, and 3 times 2 is 6. So they're both positive, so it's plus 6. 1x here being multiplied, so that's x squared. Then we're going to do the 3x times 6. 3 times 6 is 18. This one has an x, this one does not have an x, so that's just 1x being multiplied. Okay. Now we're done with the 3x. Now let's take this negative 7. Negative 7 times x squared is negative 7x squared. Then negative 7 times positive 2x is negative 14x. And then negative 7 times positive 6, that's negative 42. Now, you can see here that we only have one x cubed term and we only have one constant term. But look at this, we have plus 6x squared and we have minus 7x squared. So that's two like terms that have an x squared. Similarly, we have a plus 18x and we have a minus 14x. Both of those have x to the first power in them. So they are like terms. So we're going to combine those. So we're just going to bring down this 3x cubed. And then we're going to combine the positive 6x squared with the minus 7x squared. Well, 6 plus negative 7, that's minus 1. But we don't put a 1 in front of an x term, right? When the coefficient is 1 or negative 1, we leave the 1 off. So we're just going to write minus x squared. Then we have 18x minus 14x. Or you could say it as 18x plus negative 14x. Either way, you're doing an 18 minus a 14, and we're going to wind up with plus 4x. Then we're going to bring down the negative 42, and this is our final expression, okay? 4 parts. It winds up with 4 parts. Let's make sure that it would turn out the exact same way with this other technique, and I assure you it will. We're not going to do the whole thing, but we'll do the first step. You can see here 3x times x squared is 3x cubed. 3x times 2x is plus 6x. And 6x squared, sorry about that. And then 3x times 6 is plus 18, okay? Plus 18x. Boy, I'm really, must be almost time to go home. Okay, so now over here we've got the negative 7 times the x squared is negative 7x squared. Then the negative 7 times the 2x is negative 14x. And then negative 7 times 6 is negative 42. And sure enough, you can see the same thing. We've got the 3x cubed, we've got the plus 6x squared, we've got the plus 18x, we've got the minus 7x squared, we've got the minus 14x, and we've got the minus 42, which would result in the exact same answer that we got in the first technique that we used, okay? So this is distribution, okay? You should practice this a good bit to make sure that you are good at distributing. Ideally, most of the time you'll do a 2-term times a 2-term, but sometimes you'll see a 2-term times a 3-term.